So, what if you could see a digital disaster coming and just stop it? No, this isn't science fiction. Today, we're going to talk about a brand new kind of AI that can actually predict catastrophic system failures, sometimes minutes or even hours before they hit. We're talking about preventing digital meltdowns before they even start. But first, let's just set the stage a little. Why is this such a big deal? Well, because in our world today, everything is connected. And when a critical system goes down, the fallout isn't just big, it's massive. And you can measure it in billions, with a B. $400 billion. I mean, let that sink in for a second. That's the estimated cost of unplanned downtime for the world's biggest companies, every single year. For some of them, just 1 hour offline can cost over $5 million. The stakes here are absolutely immense. For decades, the entire game has been react and respond. Right? An alarm goes off and it's all hands on deck, engineers scrambling to fix something that's already broken. But that's just damage control. The real winning strategy, and the one we're diving into today, is this fundamental shift to predict and prevent. And look, this shift isn't really a choice anymore. Modern systems have literally millions of moving parts, code being written by other AIs. The old way of a person just setting a simple alert, tell me when CPU hits 90%, that's dead. You just can't keep up. You need a system that can figure out what normal looks like all by itself. So what's the solution? Well, this is where a brand new category of AI comes in, one that's been designed from the ground up to forecast the future of these incredibly complex systems. It's called a Time Series Foundation Model, or TSFM. And honestly, the best way to wrap your head around it is to think of it like an LLM, like ChatGPT, but for numbers. So just like ChatGPT reads a sentence to predict the next word, a TSFM reads a sequence of performance numbers to predict the next number. And here's the absolute game changer. It's one single model that works for every metric, no custom tuning needed. Okay, but here's the catch with some of the early models. Most of them have a really short memory, what we call a limited context window. So if you're looking at data every minute, they might only be able to see the last 8 hours. I mean, how are you supposed to predict a weekly pattern if you can't even see what happened last Tuesday? And this is where the real breakthrough happened. To solve this whole short memory problem, engineers came up with this brilliant new approach. It's called a multi-resolution architecture. Think of it this way. This new architecture gives the AI two different ways of looking at time at the exact same moment. First, you've got the coarse view. This is the forest. It's looking back over 3 weeks of history using data points spaced an hour apart. This lets it see the big picture, long-term trends, weekly patterns, that kind of stuff. Then you have the fine view. This is the trees. It's looking at the last 8 hours, but with data points every single minute, so it catches all the tiny, sharp changes happening right now. But here's the magic. It doesn't have to choose between them. The multi-resolution architecture literally fuses both of these views together. And not fusion, that's the secret sauce. It lets the AI understand the slow, predictable rhythm of the business week and react to a sudden, crazy spike in real time. It gets the context and the immediate details, all at once. That's the key to making these incredibly accurate predictions. And, the results really do speak for themselves. When they tested this on real-world data, the multi-resolution model was about 25% more accurate than its competitors. And remember, lower is better here. So this isn't just a cool idea, it's a massive, measurable leap in performance. Okay, so better accuracy on a chart is great, but what does that actually do for you? Let's talk about a real story of how this tech stopped a huge online retailer from having a very, very bad day. So here's the play-by-play. At time zero, the AI spots a really subtle change in checkout latency, something a person would probably miss. Just 7 minutes later, it makes this incredible prediction. There's going to be a full-blown outage in 45 minutes. That prediction creates this precious window for the team to actually do something. And sure enough, by the 24-minute mark, the fix is in. And the outage never happens. It was completely averted. This is the actual message the AI sent to the engineering team. I mean, can you imagine getting this? The entire conversation just flips. It goes from, what's going on, to, okay, we have 45 minutes to prevent an outage. It completely transforms the response. And what this does is it introduces a whole new way of thinking. For years, the tech world has been obsessed with MTTR, mean time to recovery. How fast can we fix it? Now the goal is MTTP, mean time to prevention. We're not just trying to get back up faster anymore. We're trying not to fall down in the first place.
So where does all this leave us? Well, this technology is obviously incredibly powerful, but it's not magic. It's really important to be realistic about what it can do and, what it can't.
So remember, the model works by looking for patterns from the past. That means it's not going to predict a backhoe accidentally cutting a fiber optic cable. And it's definitely not going to predict the chaos caused by the intern deploying code at 4:59 p.m. on a Friday. It just can't predict things that have no history in the data. And that is really the key takeaway here. The goal isn't to be all-knowing. It's about buying your team time. This AI dramatically shrinks the number of fires you have to fight, which lets your people focus on the truly weird, unpredictable stuff. Prediction augments your vigilance. It absolutely does not replace it. This tech is already changing how we manage our digital infrastructure. And it leaves you with this really fascinating question. If we're getting this good at predicting when a complex computer system is going to fail, what other kinds of complex systems could we see coming? In supply chains and finance, maybe even in public health.